today we are going to be looking at key features of graphs. So in our table of contents, that is going to be on page 54. Oops, sorry, I'm hitting my camera. We have 2 pages that we're going to be adding in, our key features to the graphs on the left, and then the actual graphs on the right. This is sideways, so you'll want it that when you open your notebook, like fold it backwards, hopefully you like have your spiral at the top of it. Okay, so put the top of that paper towards the spiral. Okay, then pause it if you need to take time to get those glued in. So first of all, we have just a bunch of vocabulary we're gonna look at. Talk about what these pieces mean, just because as we go throughout all of this unit and really into the rest of this trimester and into next trimester, what all these terms are and what they are in relationship to a graph. So as we look at this, okay, the domain is the set of x values in a function. So when we are talking about a domain, it's the same concept as us talking about x values. Okay, the range is going to be the set of the y values. So if we're looking at a graph and we're talking about x values and y values, right? We said yesterday that x-intercept is the horizontal, the y-intercept is that vertical, right? It's that same idea as using the words domain and range. So our domain, if that is the x-axis, that is going to be on our horizontal. And our y values will then be on our vertical. The independent variable, right? Hopefully we've heard this before through science or maybe other math classes. The independent variable is the variable that's not affected by anything. Okay, that is the same thing as our domain. That is the same thing as our x-axis. Okay, so this is the domain, the x values on the x-axis. That's where our independent variable goes. Our dependent variable, okay, this is the variable that depends on another, right? I'm going to be selling some shirts to make some money. I can't make money unless I sell shirts. So me making the money is dependent on the shirts that I'm selling. Okay, that goes with our range, which we said was our y values. So this is going to be shown on the y-axis. The x-intercept is where the graph of a function crosses the x-axis. Okay, and it is where it is equal to the y value, where the y value is equal to 0. So when we are actually looking at the coordinate plane, we are talking about where a line crosses that horizontal axis. Okay, where it hits it, where it crosses it. The y-intercept is then sort of the exact flip-flop of that, right? It's where it's going to cross the y-axis. And so for our y-intercept, that x value is going to be 0. And we saw that yesterday when we were talking about those ordered pairs, right? If you flip back a page in your notes, we know that anything that has an x value of 0 is going to be on the y-axis. So that same idea is coming up today. Where that x value is 0 is where we are on that y-axis, which is a formal name of a y-intercept. Okay, if we have an increasing function interval, okay, this is where our graph is showing that something is growing, it's increasing. It means that we are going to see something going uphill from left to right. Okay, so we're going to see something that's going like this. It might be curved. Okay, but when we are going from left to right, it's going to be going up. So decreasing is the exact opposite of that. Okay, it's showing that it's going down or it's decreasing when we read it from left to right. Okay, so we will see something that is going downhill. I mean, it could be curved and going down. The minimum is going to be the lowest value when we're looking at the y. So when we're looking up and down, that's our y-axis, where we find the lowest point. That's going to be our minimum. Our maximum is going to be the largest value, the highest value. Now, I'm using lowest and highest because we're going to be looking at a graph in a minute. If we're actually talking about the number, it's a larger number and the smaller number, right? The largest number and the smallest number. Okay, so if we turn and we look at these graphs that we have over here, we have some graphs, and then we're going to use that information to answer some things about it. So the first question, what is the y-intercept for this graph? So we said the y-intercept is where a graph crosses the y-axis. So we know that this vertical is our y-axis. Okay, and we want to know where it crosses it. Well, right here it crosses, and it's labeled at 20. Okay, so if this graph represents the distance a dog is from the front door over time, okay, when I go and I look at this, I want to be thinking about, okay, what is the distance? Okay, what is my distance at that moment? So my distance at a time of 0, this is the ordered pair. 0, 20, right? We said the x value had to be 0. So my time is 0, my distance is 20. So this represents how far the dog is from the door when 0 seconds have passed, or when no time has passed. If no time has passed, it's where we start. So it's the distance from the door to start, at start. Okay, we also have a couple flat sections of the graph. So this is asking, what do these flat sections of the graph represent? Well, we know from our key terms, things that are going uphill are increasing, right? So we know that we said this uphill section meant it was increasing. And if it was going downhill, we knew it was decreasing. But what happens if it's flat? Well, if it's not increasing and it's not decreasing, that's telling us that it is staying constant. Okay, it is a constant, and then whatever our Y label is, it's a constant position. It is a constant distance from the door. Okay, so we have a jump start on this next one. It says, at what time interval is the position increasing? So where do we see increasing? Well, we see increasing right here. Okay, and if we look at our actual values, we see that this is increasing from 1 to 3. Okay, so we have an increase when the X value is from 1 to 3 seconds. Okay, when do we see it decreasing? Well, we have our decreasing over here, right? And if we look at this, right, I'm just kind of going straight down and bring this down to see where this at. We're not quite at 5, we're a little bit before that, so maybe from 4.5 to 6 seconds. Okay, we said our maximum is our largest value. Our largest value on the Y. So going up and down, where is the highest point that we get? Well, the highest point that we get is here, and that is at 60. So our highest is going to be 60 meters. So our maximum is 60, and in this case, it's meters. Okay, and our minimum, it looks like, is down here, which is 20 meters. So basically what this tells us is that our dog is running away from home but never coming back out in the house. So this is a dog that is not well behaved. Okay, if we look at our second graph down here, so this scenario, I guess it should be to the left, displays the height of an elevator as a function of time at a local business. Each floor of the building is 4 meters above the floor below it. Okay, so what is the y-intercept for this graph? So where does it touch the y-axis? Where are we crossing the y-axis? Well, we're doing that here, and that's at a value of 8. right? We said that that y-intercept meant that our x value has to be 0. So this is 0, 8. So 0 time in seconds means 8 meters. So this means we start at a height of 8 meters. Now, if we're going to accord this rule that each floor is 4 meters, right, this would be the second floor. Our X-intercept. So our X-intercept is over here. This is where our Y value is 0. So we know our X value is 50, because we're just reading that off the graph. Our Y value is 0. Our Y value is height, so our height is 0. Okay, so this is always representing where whatever this is 0, right? Our height is 0. It's telling us at 50 seconds, our height is 0. Or we're on the floor, right? We're at the very ground level. The flat sections, right? We said above that flat sections mean constant. So this is going to be a constant height in meters. So if the elevator isn't changing its height, it's staying at a constant height, our elevator isn't changing floors, right? So our elevator maybe has stopped at a floor. Okay, during what time interval do we have something that is increasing? So here we have a couple places that are increasing, right? We have increasing here and we have increasing here. So this is going to be increasing from 0 to 8 seconds. And it's also going to be increasing, what do we think, from 10 to 20 seconds? Okay. During what time interval is it decreasing? So we have a definite decrease, one big decrease right here. Someone must be going from a top floor to the bottom floor. And that is happening, what do we think, from 40 seconds to 50 seconds? Right? I'm looking straight down. Maybe a little less than 4, maybe like 42 seconds. I don't know. Our maximum is when it's at its highest. So how high is our elevator going? Well, it looks like the height of maximum is going to 20 meters. So again, we said if this is our 4 meters per floor, we're only up 5 floors, right? Let's see, our minimum value is going to be 0 meters. So we are going from the first floor all the way up to that 5th floor.